Hello, Chem student. This section is quite long, so you can pause at any time to read the material yourself. So when we read a graduate cylinder, we often notice that for water, it curves like this, and we always read it to the middle of the meniscus. But for other substance like mercury, sometimes the meniscus is right here. So why do some substances curve down and some curve up, or convex and concave? Okay. So particles in solid, liquid, and gas move or vibrate in different way. Just know that because of the intermolecular forces in between the molecule, some material will exist as solid at room temperature, some as liquid, and some as gas. Okay. And out of those three states, gas is the only one that have empty space, so that's the only one that can be compressed. Liquid and solid usually do not compress. Okay. Once again, we already talked about forces of attraction in between molecule from 12.2, so read that for yourself. But know that liquid obviously is more dense than gas, and solid are more dense than liquid by a little bit. The only exception is for water, ice is actually less dense than liquid. The word fluid, often understood by people to just be liquid, but fluid dynamic means the study of anything that can flow and their motion. So remember, both liquid and gas can flow. And one thing that we often study in fluid dynamic is the word viscosity, or the resistance to flow. So the more viscous, or the higher the viscosity, the more it resists flowing. So higher viscosity equal slower moving liquid. Okay. And once again, the stronger, the more attracted the molecule are to each other inside a liquid, the higher the viscosity. Or the bigger the molecule and they tangle with each other more, the higher the viscosity tend to be. Now, how can you decrease the viscosity of something like the oil inside your car? When your car engine is cold, you never want to race it because the oil is still quite viscous. So one of the way to decrease the viscosity is to make the molecule have more kinetic energy, aka heat it up. So remember, temperature is directly related to kinetic energy. Or you can actually make the molecule smaller. So for some oil, they want it to be thinner or lower viscosity. They will often add molecules that are slightly smaller than the natural oil to change the viscosity. Surface tension is a unique phenomenon that exists on the surface of a liquid when it's next to another phase like air. Okay? And it is often caused by intermolecular forces like hydrogen bond. And one way to break that up is to add a surfactant. And the surfactant interfere with the bond in between the molecule, making them not as attracted to each other as much. Okay? Another word for surfactant often are soap, shampoo, detergent. So here you have a picture of a water strider. You can clearly see the spot where its leg is resting is not pointing straight down, is laying flat against the surface. So that way it spread out its weight on a bigger area and it does not puncture the invisible skin on the water. Now if you were here in person, you will see me quoting with my hand. Water don't really have an invisible skin. But what I call the invisible skin is the surface tension on that water that prevent small things from going into the water. Because the water surface are so attracted to each other, new things that are light or do not have enough pressure cannot puncture it and go in. So the word cohesion means to be attracted to each other, once again. So cohesion is the force of attraction between molecules that are basically identical. Adhesion is the force of attraction between molecules that is different. So an adhesive is able to attract things that are different surfaces, like say a piece of plastic on tape. You put a layer of adhesive in it. Now that plastic can be attracted to say your desk, which is another plastic. to your paper, which is a completely different material, or to a piece of metal. So adhesion is between two different type of molecule, and cohesion is within the same type. So if you notice water dropping down on your window on a rainy day, if one small droplet touch another one, they will combine and stick together, and that makes a bigger droplet. That's cohesive force because it's between water molecule. Now also, if you take a piece of paper towel and you put it on some water, you will notice that the water go into the paper towel. That's an example of capillary action. Or you put a straw inside water, you will notice there's a little bit of water that go into the straw. Now if you have a smaller straw, there'll be even a higher height in the amount of water that goes in. So in your paper towel, there's a bunch of tiny little tube or crevices. When you touch it onto the surface of the water or into the water, those capillary action will have the water be attracted by adhesive force to the surfaces inside those tube or crevices and go into it. So here's an example again of capillary action. The smaller the tube, the higher it goes. So if you have a really big tree that's very, very tall, like a giant redwood tree, the amount of small tiny little tube that's inside that wood is a lot smaller than, say, in a leaf of a lettuce, because the smaller the tube, the higher the water can go up into it. So yes, your plant actually lives, and it doesn't really pump water, but the water go in through the little opening in the root and through capillary action and go all the way up to the leaf where it's evaporated. And rainforest obviously makes its own rain because the water goes from the ground up into the leaf and evaporate, and when it touches cold air, it condenses and come back down into rain. Once again, solid. The reason why they're solid and they can't move is because the forces in between them are quite strong. So out of the three state of matter, solid would have probably the highest intermolecular forces. Okay. Rest of this you can read on your own. So what is a crystal? Crystal is just a repeating geometric pattern between the different type of atom that makes up that material or different type of molecule. And obviously crystal is a solid. And if you look at only one unit of a crystal, that's called a unit cell. So certain type of material have a different pattern for the unit cell. It could be like AB, AB, or in some cases could be like AB, D, E, or various combination of letter representing different atom. But it could be rectangular, it could be hexagonal, and so on and so on. Please read your book for the additional pictures. But here's some pictures of different type of unit cell. Okay, and just additional material from the book. But yes, it's kind of hard for a lot of people to realize that actually a lot of metal crystallize and do make crystal. Please do not think that all crystal are transparent, okay? There are a lot of things that crystallize, but they are not transparent. Once again, an element can exist in the same state of matter, but in different organization, different type of crystal. Same is also true that they might not be crystal, but they just exist in different arrangement, and that's called an allotrope. So if you look at carbon, aka your pencil lead, is graphite. It exists in a hexagonal ring, but when it is solid, say in diamond, it is in a tetrahedral shape. And of course, if it's not in a very organized repeating pattern, it is simply just charcoal or coal. So an element can exist in multiple arrangement at the same state and the same given temperature, and that's called allotrope. Now glass is an example of an amorphous solid. If you melt glass and you cool it super slowly over hundreds, if not thousands and thousands of years in the ground, it will make a crystal of silicon oxide. But if you melt it and you let it cool in a matter of hours or at most a day, you will get a pattern that's not organized yet because the atom did not have enough time to rearrange themselves into the most optimal, stable, or organized pattern. So when something is cooled quickly, the atom have not gotten a chance to crystallize yet. Or if it's solidified very quickly, it does not have a chance to make it a crystal pattern. It's called amorphous. So here's the 3 question. Once again, I will look for why, not just the answer. If you just put down the answer, you're not getting anything because you're just guessing unless you show me that you have proof, right? So make sure you put down the answer and why. Same here. And then of course, once you finish reading 12.3, you should be able to explain this quite well. I kind of mentioned it earlier when I talked about class.